in terms of CapEx deferral, how is capacity planning typically done in telcos today? And is the approach different between mobile and fixed networks?
Yes, I mean, capacity planning is a really interesting field. Naturally, it's a lot of money. Very large part of the budget for every telco goes to both CapEx and OpEx that are affected by putting new capacity into the networks. We talk about core capacity, access capacity, distribution networks, peering links, small CDNs, caching networks, everything. It's planning where to spend your money in the right ways is really important. It's not like a little tangential thing that some operators just handle with a few people. It's important. And what they typically do today is they look at utilization of ports or interfaces or nodes or software for that matter, if they're looking at upgrading or capacity management around pieces of software that's running in their core or their access. But most of the spending is on capacity elements like interfaces, radio equipment, switches, ports, routers, CMTSs, depending on the network, etc. So in order to understand when they need to upgrade, they have a look at the current utilization of those ports. And they have a policy that says if that utilization for some amount of time exceeds 70% or 50%, then it's time to start an upgrade. And you asked how fixed and mobile networks are different, and it's pretty simple. Fixed networks never ever want to be full, so they try to stay ahead of the so that utilization never hits 100%. At least that's their ambition, because if it hits 100%, that means that the application QoE and subscribers are going to be unhappy. You run a speed test, you have a 50 megabit plan, you get 25 megs because there's just not enough capacity in your fixed network. And fixed networks, because of the higher ARPU and other things, they always want to stay ahead of the demand. So when they see a port hit 50% or 60% or whatever their threshold is in this particular telco, they schedule it for upgrade. But scheduling it for upgrade today does not mean that it gets upgraded anytime soon, because it just takes a very long time from that decision to that capacity being in the network. On the mobile side, they can't afford to just upgrade whenever utilization on a radio node hits 100%, because that would be cost prohibitive by a very large margin. So instead, they look at, or a typical mobile operator will look at how much bandwidth is a subscriber getting on this particular radio node location in the network. And if that typical bandwidth that subscribers are getting is below some throughput, let's say 3 megabits or 2 megabits, that's the time for upgrade. So because of how much more expensive it is to put radio resources in compared to upgrading a fixed network, they have different types of policies. And sometimes in a mobile network, cost isn't enough. They just cannot upgrade because there's no radio planning in the world, new nodes, etc. It's not going to help because they're just out of frequency.
Fantastic, thank you. That's great, really clear, thank you. And how can App QoE data make capacity planning more accurate?
So because it's a lot of money, and because these upgrade cycles are really long, it's important to get the time of upgrade right. Like Samir was saying, if you get that capacity in too late, then your subscribers' QoE is going to suffer immensely. You'll lose subscribers, and it's just not good. But getting it in too soon means you're wasting CapEx and OpEx. And you want to defer that upgrade to the last minute because prices on equipment and other things are going to drop. So getting the timing right is really, really important. Now, if you're just monitoring the utilization on a port and you're seeing how that's trending, that doesn't give you enough information to do an accurate forecast of when that port is going to hit 100%, or in the case of a mobile network, when that subscriber bandwidth is going to be lower than 3 megabits, because you're not looking at what is actually driving that utilization. And there are, of course, lots of different variables in there, which is where Sandlines data and App QoE comes to its value, which is, are you getting more subscribers? That's easy to measure, and most telcos know I'm acquiring new subscribers in this location. In the Western world, most of the world really, you don't have much subscriber growth, but you do have people moving. There are places where, let's say in the US, Samir's in Dallas. A lot of people are moving to Dallas for some reason. I wouldn't, but that's just me. So capacity planning, even though the US operators are not adding that many subscribers in total, people are still moving around. So for a single node, understanding your trend of subscribers is important. Sandline isn't unique in that. Any vendor could count subscribers, but it is a variable. The next variable is how many subscribers at peak are using these heavy video applications. Now, there we're unique, because in order to understand that, you have to be able to classify these packets and see this is video. And how much of it's video, and what type of video is it? Is it Netflix or YouTube? Is it 1080p or is it 4K, etc.? So the more subscribers use video sessions, the more throughput at the same time we're going to use. So we call that application popularity. That's the second variable. The third variable is how much bandwidth does each one of those video sessions or other application sessions, how much bandwidth is each session using? And you take those three variables together, now you understand growth in that particular node. So by doing that, you can also do what if analysis. What if I get 5% more subscribers? What if Netflix changes their typical throughput for a video from 1080p to 4K? What if 20% more of the videos are 4K? What if we get 10% people on the metaverse? What if cloud gaming gains in popularity and you get 5% of the subscribers doing that using 50 megabits each, etc.? Because now you have the variables that comprise the utilization. You can do that kind of analysis, and you get much, much more accurate forecasting in when that interface is going to be full. So you won't upgrade too late, or you won't upgrade too soon. You'll upgrade when it's just right. But it also gives you one more thing. You can run that interface if hotter now, because you understand what a full interface means. You're measuring the subscriber QoE. You don't have to be afraid of a full interface, because now you see the consequences. Maybe for some reasons, in order to make this operation profitable, maybe you do have to run it hot. And maybe you do have to say, instead of full interface equals upgrade, I will run it until Netflix goes from awesome to good. That's the time to upgrade.